All right, let's see here. Triple nested integral. We want the region that's inside of the sphere and also inside of of this cylinder. Okay, so we've got a sphere of radius 5. Let's draw this.
This is going to be a similar sort of projection.
Yeah, I think a projection would be a great way to do this. Yeah, indeed. Well, so let's draw the picture just to make sure. Big sphere. And then with a little cylinder, y squared plus z squared is equal to 1. So that's a cylinder that's kind of like, it's parallel to the x-axis, kind of cuts through like this. And I want the part that's inside of both of these. And so now that I've got this picture nice and messed up, let's see what we can kind of geometrically feel at it from this picture, but then let's draw a better picture down here. And so I've got a cylinder with, now it's got kind of a rounded edge on the end over here. And then it cuts through a ways. And then it's got kind of a rounded the other way, rounded to the outside there. That's not a great picture, but it kind of, it's good enough. Everybody see what's going on here? So clearly we do not want to slice first perpendicular to the x-axis. That would be bad because we're going to hit both of these sort of edges. There's this little bit sticking out there and a little bit sticking out there.
You said we do not want to go.
Yeah, you don't want to put your dx on the outside, right? Because then you'd hit those edges. So, but yeah, as you've observed, this is a great problem for projections because the projection, weird though those edge surfaces might be, the projection into the YZ plane is easy. It's just the equation of the cylinder, y squared plus z squared equals 1. So let's take advantage of that. dy dz. So z negative 1 to 1. And yeah, that's right. And then y negative square root of 1 minus z squared to positive square root of 1 minus z squared. And now all that remains is to figure out the bounds on x. So for any given value of y and z, I need to solve for x on these two surfaces. So I got to, from my picture, I need to deduce where do those surfaces come from? Well, look, they came from this. They came from the sphere. So I really just need to solve for x on the sphere. And that's easy. X is plus or minus square root of 25 minus y squared, minus z squared. And the plus is the point over there, and the minus is the point back there. And namely, the plus is the upper bound for x, the minus is the lower bound for x. So just negative square root to square root. Yeah, and then our integrand f, whatever. Cool? Everybody good?